Alright, so we're taking a look at this topic 46 study sheet, some things that we need to know. Many of these things are informational, but we do have some math things, and I do want to go over those math things within this particular lesson. The first one says, determine the mass of a 25 centimeter cubed object of this density of 2.16. Remember, anytime we're doing this, go to the triangle. We're going to cover up the one we're looking for in order to get our formula. In this case, it's density multiplied by volume. So we're going to take the density, which is 2.16, multiply it by 25. In order to get the mass, 25 times 2.16 is 54 grams. Grams comes from here, and if it's a 3-mark question, remember you need to show your formula, your work, and your answer with proper units in order to get full marks. Okay, we've got lots of information about buoyancy force, and we got some questions dealing with topic 5 and 6 together. So we've got a 50-gram object with an average density of 0.75 grams per centimeter cubed in seawater. And we want to know what is the volume of the object. Well, density, mass, volume. So volume is equal to mass over density. We're going to take the 50 divided by 0.75. So 50 divided by 0.75 means that it is 66.7 centimeters cubed. What mass of water must be displaced? Well, in order to support a 50-gram object, 50 grams of water must be displaced. Right? If we think about this object, we got 50 grams down, which means we need to displace 50 grams in order to hold it up with an equivalent buoyancy force. That is Archimedes' principle. So if the density of water is this, what volume of water must be displaced before it floats? Well, we've got the mass and we've got this density. Volume is equal to mass over density. That mass is still 50 grams, but we're now dealing with the seawater, which means 50 divided by 0.103. 50 divided by 1.03. Gets you 48.5 milliliters. What volume of the object is remaining above the surface of the sea level? Well, if the object has a volume of 66.7, right, so this total volume is 66.7, but 66.7, but it needs to displace 48.5 in the water, so this volume is 48.5. How much is left just on top? So all of this 67.5. We've taken away 48.5. That leaves you with 18.2 milliliters on top. Now, it should be noted that 1 centimeter cubed does equal 1 milliliter. That those volumes are equivalent. It's just we use this for solids and this one for liquids. And we get that simply by taking the 66.7 minus the 48.5 to get the 18.2. So if we draw a diagram showing the forces on the object, well, we would have a 0.5 Newton force down and a 0.5 Newton up. Because this is a mass, this would be the equivalent weight on Earth. And it's floating in the water there. Jaden put a mass in a beaker of water. The results are shown below. Well, given the two volumes, the difference here of 5.6 milliliters equals the volume of the object. So now to find the density, that's mass divided by volume. 12.3 divided by 5.6. 0.3 divided by 5.6, that calculates to a density of 2.19 grams per milliliter. We know that because this is grams and this is milliliters. Taking a look at dealing with a liquid, we need to take the mass of the container and liquid and subtract it from the mass of just the container, which means the liquid has a mass of 5.9 grams. And now we can find the density of the liquid. 5.9, and it's 17.7 milliliters, which means 5.9 divided by 17.7, that gets you a density of 0.33 grams per milliliter. I do hope that this helps, and you can pause that video and go through, but that would help with the answers to some of the math things dealing with your study sheet.